Good morning or good day, everyone. Today, we are going to be talking about pollution. And because a lot of the pollutions we're talking about are water focused, and because I have a lot of great species of the day, I've picked a few water themed ones for us to start with today. So, here you can see the goblin shark. Again, I'm going to let you watch those YouTube videos, but you can see how it lives on a lot of different coasts. Definitely a very creepy, deep water shark there. Creepy looking. We also have the bubble eye goldfish. Um, these, I believe, only do well in aquariums due to their bred very large bubbly eyes. And surprise, surprise, these little cuties eat fish food. Another one that one of your peers found was the hawksbill sea turtle, reptiles that eat fish, algae, jellyfish, sea urchins, hard shell to protect it from predators. They like to live in coral reefs, lagoons, and rocky areas where they can find yummy foods. We have the northern stargazer, another deep water fish. It's been a theme recently from some of you. It is 120 feet or deeper, found in the western Atlantic. They bury themselves in the sand, jump out with their creepy face at their prey, and because they're always looking up for their prey to swim over them, they're called northern stargazers. They also can produce electrical currents, and I guess are doing well. So another video there. All these links should work, so enjoy those at your leisure. I'll post this when I post the video. And lastly, I have the sea wasp, a very deadly version of a box jellyfish found in Australia. Looks for food during the day, sleeps at night, can be as large as a basketball. So, one of those things that lurks in the water. So, like I said, today we're talking about pollution of different types. So pollution is considered any kind of contaminant that comes to the environment. And something that's of interesting to note, especially with humans making our impacts on Earth, is that a contaminant doesn't always have to be a toxic chemical or a poison. It could be something that naturally occurs in an environment, like nitrogen or phosphorus. But when we over fertilize, we can add extreme amounts. So once you add more than would naturally be found into an environment, that is also considered a pollutant. So we're going to focus today on light, noise, solid waste, and chemicals. So, light pollution. I don't know where you live, but if you go out at night, there's often a lot of lights that surround you. And depending on how close or far away you live from a city, it could be really hard sometimes to even see the stars. So when we look at light pollution, scientists have actually broken it into categories: sky glow, over illumination, and light trespass that kind of moves into forests and areas where there really shouldn't be any light at all. So, how can light pollution affect animals? Probably negatively. Well, navigation and orientation. It can affect how they reproduce. A lot of animals that would be mating at night might not do it if there's light in the area. It can actually delay the rate that frogs metamorphosize, thus making it harder for them to turn into adults. It can alter the timing of foraging behavior and also impact communication. For instance, coyotes, groups of adult coyotes, will howl to mark territory, and they wait until it's dark to do that. And if it doesn't really get dark or it gets dark later when everyone turns off their house lights, they have less time to basically assert their dominance. So, light pollution in sea turtles. This is a common example that I've definitely heard of before. The idea that when sea turtles hatch, they immediately need to go to the ocean for safety and food, so that birds and prey don't get on them, they don't get stepped on, and they use moonlight to navigate. And so, researchers have done studies to see what would happen if there's a lot of lights along the beach in the opposite direction of the ocean. Um, and so they studied that and they looked at different areas. They didn't add more light than was already there, but they found areas where there wasn't a lot of light pollution, where there was no light coming from the beach areas. And in this first picture here, you can see that the turtles were able to make a straight path right to the ocean. If there was light kind of off to the side of where they were, they eventually made it to the ocean, but they often took a more diagonal path instead of a more direct route. Some of them kind of got sidetracked by the light over here, and then eventually found the ocean themselves. And then when they have light all over the beach, imagine, a place like this where your nest is right in front of all those hotels. And they found them taking all kinds of circular paths in different directions. Some didn't make it. Some were taking loops and woggles and swiggles, and eventually, after 2 hours, were able to make it to the sea. These are obviously small little baby turtles. They've just hatched. They don't have a lot of energy. They need the protection of the ocean, and they are extremely disoriented from that light source. Light pollution also affects migrating birds. So, 450 different species of birds migrate across North America at night. And so they use the moon and the stars for navigation. So you can imagine if there's a lot of lights underneath them and lights above them, it's harder for them to see it because of light pollution, and they need that light from the sky for navigation. This was a really interesting concept, not one I was aware of, but this idea that once they leave a light source, like these direct beams, these are actually coming off of the 9/11 memorial in New York City. And birds were flying through and got disoriented in the light source, and then they can't really leave it. It disorients them so much that they're basically flying in circles, they're crashing into each other, they're totally confused. And so they were talking about the numbers of birds found beneath this light, dead or injured. And also, this kind of light reflecting off buildings and windows and things like that can also cause 100 million to a billion birds' deaths a year just by hitting glass in the United States. Here's a map of light pollution areas in across our country. You can obviously see the more heavily populated areas are going to have higher levels of light pollution. Here specifically is Washington. We're obviously down here. Sorry about that. But the Seattle area in particular is quite lit up at night. So one thing we can do is selectively turn off lights. If we don't need them, why put them on? Another option is different types of lights. So here you can see a spotlight that's aimed sideways. It doesn't show the ground where people are walking very much. A whole lot of that light energy is wasted and being shot upwards. So just directing the angle of a light and using a low watt bulb can really make a difference of giving us the light we need without impacting the light of our neighbors or of the birds and other animals as well. Another thing you can do is change the color of your lights. Blue and green light bulbs are less disorienting than yellow ones because yellow ones obviously match the stars and the moon. There's a 10-minute video about light pollution if you want to watch that, linked below. Another type of pollution that affects our wildlife is noise pollution. Obviously, unwanted noise can interact with different aspects of a wildlife experience. For instance, communication. Female gray tree frogs take longer to locate calling males if there's a lot of traffic. It's a low, deep sound, and in order for them to easily hear that and not have it be muffled out by traffic, ends up being a problem. Also, mammals, marine mammals, whales, and dolphins. We've all heard about them echolocating underwater and communicating with each other underwater. There's been some kind of horrifying articles about Navy testing of sound radar and things like that in areas, and it disorients dolphins, whales. They'll beach themselves. They'll become ill. It'll actually damage their hearing so that they can't communicate and echolocate and find food. So like I said, here's a picture of them. It can also alter the way they behave. If they hear sounds, when they send out a sound signal, they're going to misinterpret that information. It can cause them to become disoriented. It can injure their sensitive ears. Whales can communicate miles and miles apart, so they have very sensitive hearing. If they get a really loud booming sound near them, just like you and your headphones sometimes, it can cause sensitivity and damage and even hemorrhaging of their tissues. Noise pollution affects wildlife, specifically birds. Male nightingales sing songs to mark their territory and to attract mates. And if they live in noisy areas, what do you think happens? Well, when they live in louder areas, they get louder. And so, what scientists have noticed is that if they're in places with more noise from an urban setting, they have to sing louder. So, on weekday mornings, like during traffic mornings, they sing really loud, and they don't sing as loud on weekends when there's less traffic and less ambient sound. So obviously there's going to be some negative impacts to these birds who are having to sing at a higher level than they kind of naturally would. put a strain on them. But what you can see here is that as the environmental noise level goes up, the song level that the bird is going has to increase as well. So if there isn't environmental noise in a certain spot, they'd be singing at this decibel, and then they have to increase their decibels to be heard. Another type of pollution that a lot of us think of, especially those in first semester, after reading garbology, is solid waste. And we can see a bunch of images of solid waste very visible floating in and around water. Global wind patterns match global water patterns and current circulations. And so, because of that, garbage and solid waste and trash and plastic and all, rope and all those things that get left or dumped or fallen into water tend to gather up in certain areas. And so, you've probably heard of the Pacific Garbage Patch before. Because of the way currents go, we have one kind of off of our coast. We have one over off of Asia's coast, and then now it's all kind of coming together. And so some from this garbage trench is going, trash area is going over here. So we're still seeing patterns where basically this garbage and plastic and rope and anything that can kind of styrofoam, those kinds of things all gather together and can be really dangerous for marine animals. However, they also provide homes for some of those lower trophic level animals, and then the ones that want to eat it potentially eat plastic instead and to their detriment. So solid waste impacts wildlife. You can see in the stomach of this bird that has died, kind of like the whale we read about in garbology, that it is mostly full of plastic and probably starved to death due to the fact that there was no room left in its stomach for it to eat food. We see entanglement issues like this poor penguin here that's all trapped and wrapped up in plastic. It looks like a rope. And chemical pollution as well. When that plastic degrades, it actually negatively impacts the animals and can cause, I think, liver and kidney failure. So, disappointing graph, but it makes sense when you consider plastic was invented in the 1950s. So this graph starts in 1962. How much plastic was ingested by seabirds, according to literature, when they found dead birds and they looked in their stomachs. In 1962, it was close to 0 species. By 2010, 80 different species of seabirds themselves were found to have very large numbers of plastic ingestion. So very disappointing, definitely a problem that impacts our wildlife. Chemical pollution also, obviously, if we pollute our environment and make it less healthy, it's going to make less healthy resources for our wildlife. I look at all these cars and think about all the air pollution coming from them. This is sewage, raw sewage going into the water, and we're going to talk about that. One interesting thing that's happened with COVID-19 is that the amounts of nitrogen and sulfuric gases and acids that are released into the air because of combustion have absolutely decreased. And so our air quality is actually improving across the world right now with decreased people on the roads and things like that. But you can see here, fuel combustion, like I said, cars is the biggest cause of sulfur dioxide. And so not having as many cars on the road is definitely improving that in our environment right now. Nitrogen oxides as well come from fuel combustion, being its number 2 source. So right now, taking a break from our cars is helping our world. However, putting these pollutions in the air, and they don't only come from cars, can cause what you've all heard of before, acid rain. Basically, there's acids in the sky, the rain falls down, or even dust particles catch the material, and when it settles down, it makes a more acidic environment. It can wash into streams and lakes and rivers. It can seep into the ground and the soil and affect certain plants, which are habitats and food sources for wildlife. And obviously, if it gets into a lake or stream, that is literally the environment for aquatic animals. Chemical pollution is also serious when we have oil spills, raw sewage that goes into a system. I took a class years ago to a sewage treatment plant. I don't think they were ever going to go on a field trip with me again. But a crazy thing about sewage treatment plants, if they get over full of water, because they also get all of the runoff from the roads and the roadways oftentimes. Now, when we have signage, because we live near the Columbia and it says don't dump drains to Columbia, that does go directly to the Columbia without getting treated. But if you're in more of a landlocked city, any of the curb water and things like that that washes off the roads actually goes to the same water treatment plant as sewage does. And so it all gets combined and then treated before released into smaller rivers and lakes and things like that. However, when there's way too much rain, say you have a deluge of rain and it overruns the system, raw sewage is literally dumped into wherever they would be releasing the clean water. And that's in the US. So you can imagine in countries that don't have the same capacity that we have. Other types of chemical pollution you find in soil and water, like I said before, pesticides, herbicides, fertilizers. Putting extra of stuff that's naturally in there is also a pollutant and has negative impacts to the environment and the wildlife that lives there. You've probably all heard of the Deepwater Horizon oil spill in 2010. Big explosion released 4.2 million barrels of oil, raw oil. And to compare that, the big one before this was the Exxon Valdez up in Alaska, and they released about 250,000 barrels. So 4.2 million from this Deepwater Horizon spill was a absolutely unprecedented, massive oil spill. So scientists have obviously been doing research. While there was great attempts to clean it up, obviously there was not 100% success. What they found was that low trophic level fish, that means the fish that eat like algae and the fish that eat the plants, those lower ones on the trophic level, had abnormalities because of the stuff they were eating was growing in this unhealthy water. They found predatory fish that were eating from higher up on the food chain actually had toxic results in their heart muscles, and the way that that worked and weakened hearts. They found less benthic organisms. Benthos is the ground of the underwater environment. And so less things were able to grow and succeed because oil had sunk into there, creating that an unhealthy environment. And a quarter of all of the coral communities nearby had more than 90% of the coral reefs there impacted negatively. So obviously, those are really good breeding grounds and homes for food for lots of different animals. So many marine mammals and animals were affected by it. So one thing that scientists want to do is check out the dolphins that lived in the area. So a year after the spill began, they began to capture health assessments for the animals. And what they found was that the dolphins showed evidence of toxicity. They were 5 times more likely to show that they had moderate to severe lung disease. Well, how do you check if a dolphin has lung disease? How long can it hold its breath? If it can't hold it as long as it should, it has damage to its lungs. So researchers said, well, okay, we know these dolphins are damaged. Can they recover? How successful are they going to be in the future? So they went back in 2015 to kind of follow up on their research. And so they used the mark recapture method, which we've talked about before. They did transect lines where they followed certain paths and they wanted to see how the animals were doing. They also looked at reproductive outcome, how many babies there were when they were counting these different areas that they could find. And then they attached satellites to some and tried to figure out where they were going to kind of help figure out the health of the animals here in this bay. And what they found was before the oil spill, animals that basically made it, or based on the numbers of adults, they would have about an 80% success rate in having babies each year. After the oil spill, only about 20% success rate. So way fewer juvenile dolphins were found. Now, of the juveniles that were born, again, based on all their tracking and research, before the oil spill, they would have expected 95 to 96% survival of newborns. And afterwards, they had 86% survival. So 60% less dolphins were being born, 10% less of those born were surviving. So obviously having an impact on the mammals 5 years later. Another big problem in that area anyway is eutrophication. Eutrophication is basically a science word that means when you put a lot of fertilizers and nutrients that shouldn't be there, too much algae grows, and you have what used to call an algal bloom. When the algae dies, then it all has to be decomposed, and the decomposition process of that basically uses up all of the oxygen in the water, and fish can literally suffocate and die because there isn't enough oxygen because all the oxygen's being used for that decomposition. So oftentimes algal blooms can lead to fish death. And actually, if you've been to Lacamas Lake lately, there is a toxic algal bloom. So potential for lack of oxygen in the system, but also some algae produce toxins as well that are unhealthy for the environment. So as I said before, with different fertilizers and things like that, getting too much nitrogen and phosphorus in here and all the sunlight allows algae to do really well, which might sound good because that's a good food for fish. But as the algae dies, it decomposes, it uses up oxygen in the process of that decomposition, and it can reduce oxygen levels to the point of killing fish. So here is a map kind of showing us areas where water resources have eutrophication. So you can see anywhere in dark green isn't really impacted. And as you get darker and darker in color, we see greater and greater human impacts. If you look at the area of the United States where we see a lot of eutrophication, that's also an area where we have a lot of our food farming, which kind of makes sense. Oh, and sorry, these little white dots all along the coast are hypoxic systems. So that's areas where the rivers are flowing towards the ocean and releasing all of that nutrients, which is causing low oxygen systems, which impacts wildlife. So here specifically looking a little closer, when we look at those eutrophic conditions, we're seeing high eutrophication on the East Coast, and we're seeing a lot of different locations where it can exist on all of our coasts. Why? Well, I think this map kind of shows us. So these are the 4, 5, 6, what is it? 6 big rivers leading all to this one basin. And they all have very large areas of land. And so everything in this pink area basically drains to the upper Mississippi, and everything here drains to the Ohio River Basin, and all of this land to the Missouri River Basin. So this isn't an issue of a farmer fertilizing. This is our entire growing area, or a major growing area in the United States, for constantly farming, the use of fertilizers, and then building up in all those streams and tributaries leading to the rivers, and then all dumping in one bay. And you can imagine that the situation for hypoxia because of the algae blooms and the algae death would be very high. So this is actually a picture of the eutrophication after kind of a season where water is flowing. And you can see all along the coast, which is often where there's shallow waters and things that are growing, and fish and coral reefs and food can get very unhealthy for animals. Lead to big die-offs of fish, and therefore birds that eat the fish and mammals that eat those foods if they don't get out of that area fast enough. The mammals obviously aren't breathing the oxygen underwater, they're coming up to breathe, but they're relying on those other wildlife as food sources. So that is our depressing lesson on pollution, but we'll talk about some positives later on. Thank you and have a good day.